Hey guys, welcome to Solving Inequalities, and today's topic is actually Intro to Inequalities. So we're introducing inequalities, which I'm sure many of you have seen and or done before. So we're just really reviewing and recapping what an inequality is. So equations have equal signs. Inequalities have inequality signs. So let's review really quick what those inequality symbols are. We have the less than sign, which kind of looks like an L tipped kind of to its side there, right? So we've got the less than sign. We have the less than or equal to sign, which means that it's got to be smaller than or equal to that number. We have the greater than sign and the greater than or equal to. So the line underneath signifies the or equal to component. And then the way to remember which one's less than is think of the letter L and then kind of tip it over, and you've got your less than sign. And if it's not less than, then it's greater than. So we're going to be talking first about graphing these inequalities on what we call a number line. And we've worked with number lines before. Number lines is basically a horizontal line with 0 in the middle. Our negative numbers decreasing to the left, and our positive numbers increasing to the right. When you see a number line and you read it from left to right, that values get bigger. These arrows mean that this goes on forever in either direction. So you don't have to, numbers are infinite, right? And we've got all our negatives over here moving all the way over to our positives. So to graph the inequality on a number line, we're going to use open circles for less thans and greater thans, and we're going to use closed circles for less than or equal to and greater than or equal to. Okay, so let me show you what I mean by that. Let's say we want to graph x is greater than -8. Okay, so I'm going to make sure that -8 is on the number line, and then I'm going to build around it. So these should be getting smaller and these should be getting bigger. Since it is greater than, I'm going to put an open circle on -8 and draw an arrow pointing towards all the numbers for x that are bigger than -8. And these are all the numbers that are bigger than -8. Now this graph represents all values greater than -8. These are values that are not greater than -8. So this is the graph for that inequality. Now, if we were to do a less than, let's look at this less than -3. Again, we have to make sure we put -3 on the number line. So I'm just going to pick any spot. Let's put it here. And then build around it. So these should be getting smaller. And these should be getting bigger. Okay. It is less than, so we're going to put an open circle on -3. And we want to underline values that are smaller than -3, smaller than -3. So those are the values that are smaller than -3. So this green graph represents all values for m that are smaller than -3. Taking a look at a greater than or equal to one, let's look at p is greater than or equal to 14. So put 14 and then just build around it. So this should be going smaller and this should be going bigger because it increases from left to right. Greater than or equal to, so I'm going to put a closed circle because it could be 14 and it could be any value larger than 14, which are these numbers illustrated by this arrow. So this is the graph of p greater than or equal to 14. Now watch for number 6. It says -2 is smaller than or equal to n. So we are going to use a closed circle because it's less than or equal to. We also need to make sure -2 is on our number line. So let me build that for you here. And we're going to use a closed circle on -2. But now read it carefully. It says -2 is smaller than n. -2 is smaller than this number and this number and this number and this number. So n could be any of these values because -2 is smaller than all of these numbers. -2 is smaller than -1, then 0, then 1, then 2, then 50, and so on and so forth. So my graph for -2 is smaller than or equal to n will be looking like that. So what you are drawing when you draw these graphs is you are drawing all the possible values that the variable can become. When you are drawing all the possible values that that variable can be, like numbers that you can actually put here that will make a true statement. So you'll get some time to be able to practice that skill, but I wanted to go ahead and divert your attention to translating inequalities from English into math. And for the most part, it's pretty straightforward, except there are a few phrases that I want to highlight here for you. The phrase at least, okay, at least is at minimum. So when you say that something must be at least or at minimum something, then that means that you want more than it, right? At minimum, I need at minimum $5. That means I need like $5 or more dollars. So at least is a greater than or equal to. At most, okay, at most is like the most that something can be, the largest that something can be. So you'll take at most 15 people to your party. That means that you'll take no more than 15, right? No more than 15, so you want to take less than or equal to 15. At most is a less than or equal to, and so is no more than. No more than and at most mean the same thing. So when we look at number 9, a number is at least 2. A number is at minimum, at least, greater than or equal to, I'm sorry, not 2, -2. Greater than or equal to -2. A number is at least -2. Larger than or equal to -2. Not smaller than it, because it's at minimum -2. So you'll take like more than that. As opposed to number 10, a number is no more than 9. No more than 9. So 9 is the highest you'll go. So x has to be smaller than or equal to 9. A number is at most 40. At most 40, so smaller than or equal to 40. At most 40, no more than 40. So then you can go ahead and pause the video and graph these 3. And then when you unpause the video, you can check your work. Okay, so all of these graphs will have closed circles on the numbers because they are or equal to. And notice how the arrow is pointing towards the values for x, in this case that are larger than or equal to -2, values for x that are smaller than 9, and values for x that are smaller than 40. For this last set, you're going to state whether the number is a solution to the given inequality. Being a solution to the given inequality means that it fits and makes it true. Okay, so being a solution means that it fits and makes it true. So for number 12, for example, we've got x is greater than or equal to -6 as our inequality, and we're checking to see if 4 is a solution. So basically, we're seeing is 4 greater than or equal to -6? Well, 4 is bigger than or equal to -6. This is true, so 4 is a solution to the inequality x is greater than or equal to -6. So go ahead and with that knowledge, try the 13 through 17, pause the video, try them out on your own, and then unpause to check your answers. So here we go. For number 13, 11 is less than 8. That is false, so 11 is not a solution. 14, 4/3 is less than or equal to 2. 4/3 is 1 1/3. That is definitely smaller than or equal to 2, so that is true. 4/3 is a solution. 15 is greater than 15. That is false. 15 is not bigger than itself. Now, if it would have said 15 is greater than or equal to, then it would have been true, but it didn't. So that is false. 15 is not a solution. Number 16, 1.7 is smaller than or equal to -1.6. That is false. 1.7 is not a solution, which brings us to 17 that required a little bit of thinking. Started with negative 3/2 is larger than or equal to negative 9/5. I went ahead and changed them into mixed numbers and got negative 1/2. Negative 1 1/2 is greater than or equal to negative 1 4/5. There's my mixed numbers. I'm like, I think this would be easier to compare if we had them as decimals. So I changed them into decimals. Negative 1 1/2 is the same as negative 1.5. And negative 1 4/5 is the same as negative 1.8. How do we know that? Well, 4 out of 5 is the same as 80 out of 100. So there's the 1.8. Okay. And then, yeah, negative 1.5 is definitely bigger than negative 1.8 because since we are negative, this is the larger value. If we were positive, this would be the larger value. This is then true. So it looks like negative 3/2 is a solution. Now that you have been introduced to inequalities, we will be working with them more, solving them in two-step and multi-step inequalities. Thanks for watching.